So for today's problem set 3, we will be answering these 3 questions. So the first question asks us to, it's pretty much asking us to find the width of a flat metal sheet that is needed to make the panel. So far the roof can be modeled by a sine curve. So here's how I approach this problem. I'm not quite sure if this is correct or not, but I tried putting together the best I could. But this is what I wrote. So we know that the length is equal to arc length of the graph, which is y equals to sine pi x by 8, and this is our range 0 less than or greater to x less than or greater to 32. So if we differentiate of y with respect to x, so dy of dx equals to pi by 8 cos pi x by over 8. And now we're trying to find the width using the arc length formula, given that the range is divided towards which is 0, 0 to 32. Those are our differential values. So the square root and just plug it into the formula. 1 plus pi by cos pi x squared. And after putting this into my graphical calculator, this is the value that I ended up with, and that would be in inches. So W, that's 32.2001 inches. And moving on to the second question. Second question is asking us to find the area and the surface area of the dish given that the diameter and the maximum depth, which is 12 and 3 feet respectively. So with this one, you place the central axis of the dish along the y-axis. So you place the central axis along the y-axis, which is right there. So the lowest point of the dish is at the origin. The lowest point is at the origin right there. So diameter of the dish is 12. It's 12. Depth of the dish is 3 feet from on here, 3 feet. The radius is 6. So as you see that we have a6 squared equals to 3 area was 3 by 36. 12 times 3, 36. 112. So we now know that the area is 1 over 12. Now that the equation of the curve becomes y equals to 1 to x squared. Now if we differentiate that, so the 12 becomes 6, we cancel it out to 1, 1, 6, we get dy over dx equals to 1, 6 x, and taking square on both sides, we get dy dx square equals to 1 over 36 x squared. Taking 1 on both sides, adding plus 1 on both sides, we get 1 plus 1 36 square, 1 plus dy dx square. As we can see now, taking 36 to the top, 36, having a common denominator, 36 over x squared, then we square root that, make this 6, square it, that will give 36, 36 again, which is pretty much the same thing, but we're just square rooting it. So now we know that square root of 1 plus dy over dx square is this value right here. So now we're trying to find the surface area, and we know that this is our differential range, 0 to 6. 6 is the radius, and it's starting out at 0. So you know that's our range. Plugging it into the formula, 2 pi x square root of 1 plus dy dx square into dx. We know that this value is right here. And now we found that value right here. So we just plug this value into this formula right here and place with this, and that's what I did right here. I plugged it in right here. After we should 36, the 6 goes here, 2 cancels for 1, 3, we get 1 by 3. So this becomes 36, x squared remains the same, dx, that's our first equation. So we can let 36 plus x squared be t. And if we differentiate with that respect to x, x becomes 2x, 36 becomes 0, 2x dx will equal to dt. And taking 2 to the bottom side, x dx equals to dt over 2. Now we can tell that when x equals to 0, t is 36, and when x equals to 6, t is 72. So to find surface area, so 1/3 pi differentiate with 36 and 36, square root of t dt over 2. So we know that 1/6 pi differentiate of 36 to 72, square root becomes 1/2. When you're differentiating, it becomes 1/2. Further, after differentiating, you get 3 over 2. The 2 comes to the bottom, 2 cancels out, and cancels out the 6 for 3. So now we end up with 1/3 pi t3 by 2 over 3, 72 over 36. The surface area becomes 1/9 pi, and 72 square root of 22 minus 36 square root of 32, and we can evaluate that to t1 into t1 equals to t1 plus 1, which equals to, I don't know why that's cut off, t3 by 2. That's what it is. Yeah, it is t3 by 2, and we get the surface area value, which is 134.150 square. And this is working that I showed. So the third question is asking us, strong winds blow directly at the base of the building, exerting pressure of 150 nanometers square. The ground increasing the height according to various height. Calculate the force of the building, which is the measure of resistance that must be included in the design of the building. Seismic calculate force. You know that pressure equals to force over area. Differentiate d over f. Taking dA to the other side. You know, force equals to PA. Differentiate P3A, force 150, and then that's the ground. Now we know that area equals to x over dy. We know our x values from 0 to 87, 0 to 22, taking py equals to 150 plus 2y. Using this calculation, we can differentiate that 150 plus 2y, differentiate that, and if we do 150 into 22 here, which is 2,300, 22 squared should give us 484. Multiplying, if you put together these two values, you should get 3,784. And when you multiply that with 87, which is the value right here, you should get 3,200 and 329,208 Newton, which can also be converted into 3.29 into 10 to the power 5 Newton.